this textbook.
Okay. You sure you don't want to just pay for it and keep it?
Probably not. We weren't supposed to do like the second page of the topics that be on the AP exam too, right?
That's correct.
Okay.
That is part of what we'll do today. You're back.
Yes, I'm back.
I was starting to think you disappeared on us.
Yeah, it's a long week. I was like texting Jim just like check what I got on those sheets,
Okay.
and I don't know if I did them right.
What sheets?
She was confused on some, and I was confused on like the.
I shared the answers.
Oh, you did? Cause I checked on the.
recording.
Okay, I checked on your website and I didn't have.
No, like what I did, like I reminded them of this stuff verbally, wrote it down with them. And then I said, I want you to go back to this one, the answer's this. And we did this again, notes again. I'm like, I want you to try this one, the answer's that. So you pull up the class recording again. You can see. But she should have those down too. You need to hurry.
129 and 131. I'll go first.
We have to try the 131, the thing from last class, or is it just?
Not yet. Just the one from 2 classes ago. And
Oh, it's just 129.
yeah, it's all up there. I never make y'all turn anything in that I don't type on the board.
Yeah, there's.
Henry.
It's this. It should be over there. Is that it? Yeah, that's. I think. Yeah.
Okay, start off. We're going to do our 2-question mini quiz.
This is fun to mine was great, but that's because.
So if you have a calculator out, a calculator's not going to help you with either one of these. And you should number it as 132. Once you get it.
I'm so confused.
not the rest. It's gonna be part one. Once you finish your mini quiz, I'm asking you to turn two things in. One of them is the mini quiz. Obviously, I need that back to see what you did. And 129. 129 was topics that will be on the AP exam part one. So that was for 2 classes ago. You have your assignments numbered, should be easy to match up. It's written up on there on the board. Of course, if you turned it in on Google Classroom, that's fine, and if you turned it in before class, that's fine too. Those are the 2 things I'm going to be putting in the gradebook.
Give it a staple.
Okay, if you're still working on that, that's fine, but try to finish up in the next minute or two here. Again, there's two things I'm asking you to turn in, the quiz and topics that you will see on the AP exam part 1. That was from 2 classes ago. It should be numbered 129 in the binder. But for the rest of us, let's go ahead and move on. So we're gonna look at this other slideshow for 2 minutes.
Yeah.
Listen, I've told you about it each day, but I'm not gonna spend much time on it. It did come up in my last class that I guess there was some confusion about the first slide. And so I guess I will let this sit for a little bit longer. I just didn't write it up very well. But the pass rate for the FHS numbers are on the left. The numbers on the right are a little bit more broke down, but those are my student scores. I can't see like the whole high schools, like how many and who got a 1, who got a 2, unless they were my students. So that's the stuff to the right versus the stuff to the left. So I only do that because if you know, don't some schools only accept a 4 or 5 maybe?
Yeah.
So that gives you a little better idea of how many people get a 4 or 5. Of course, the 2021 year was the virtual COVID year, so. All right, worldwide percentages for 1, 2, 3, and 4 don't change much. The grading scale is sliding, so make sure that you try your best that you can.
It's for me and Lauren.
Thank you. Yeah, we'll need to stay for a moment to do the mini quiz. So, some stuff from College Board Grader. Again, this is a couple years old, but I suspect it's pretty common. Half of the 2 scores would be a 3 with 3 more points. 11 points to go from a 2 to a 4. Calculator FRQs, make sure you're writing down what you put in the calculator to show your work. Any explanation, justification more than a sentence is probably on the wrong track, and you don't have to simplify any arithmetic. He claimed 1 FRQ is always a geometric graph. We practiced like 4 of those a couple weeks ago. He claimed 1 of them is always a rate in, rate out, which we practiced this week on Tuesday, and I gave you an optional one on the back. Always round to 3 decimal places, and if it says a function is differentiable, go ahead and say it is. That means it is also continuous. Differentiable functions are always continuous, but if it doesn't need it, it doesn't take you 5 seconds to write it down, and if you do need it, sometimes there's a point or 2 hidden behind that. Okay, you guys gave me some reasons that you think to pass the AP exam. 6th period added some. You guys had nothing to add yesterday. 6th period had nothing to add yesterday. Anything else? Okay, that's fine if y'all don't think of it. There's still one I think of, but I'll share that with you before the AP time. Okay, so next up, like we have been doing, and just to be clear about this, this is, as you guys know, I try to be very strategic on what I ask you to do, especially on our last days here. So the most common type, in my opinion, are those geometric graph type. We did 4 of those FRQs in the big packet weeks ago. According to that grader and that slideshow I just looked at, he said 1 is always a rate in, rate out. That's why we did one of those on Tuesday. And I hope that shows you whether you should feel confident about that and prioritize something else versus if you're not confident on it, maybe you need to do the one on the back. Maybe you need to go and do some extra ones. Remember this big packet I gave you, the AP Survival Guide? There's one page that kind of breaks these down. So that rate in, rate out one is type 1, and it was asked in 2002. 4, 5, 6, 7, 8, 9, 10, 10, 13, 14, 15, and 17. So if you know that's your weakness, I don't know how to spell it out for you that you should expect to see that on the AP test, and I'm trying to provide you as much practice as possible. Short of making 300-page copies, just copying them out for you. And then yesterday we did a particle motion / linear motion, so same idea. If you felt pretty good about that, I probably wouldn't spend my time studying it. I would do something else. but there was one on the back, and then there's another dozen or so on this handout if you needed them. So today we are looking at type 5, which is tables and Riemann sums. And it appears that these have shown up in 2001, 2, 3, 5, 7, 8, 9, 10, 11, 12, 13, 15, 16, and 17. And again, I typed this up to make it look a little bit nicer, but the person who did the research on this, they stopped tracking after 2017, so it's happened after that as well. So once again, this is very likely, these parts are very likely to show up on your AP test. And by giving you class time to do these, I'm just trying to help you see if this is one that you should feel confident about and don't study something else, versus this is one you're not confident about, it's likely to be on the AP test, you do need to study it. So that's what we are going to do next. So 133 is the FRQ page, bless you. It's going to be 2005 FRQ 3, and again, I'm very strategic in the parts that I did say. But after that, I kind of just picked one of those at random. So the 2005 FRQ3 is the one that I picked. And this one, you see the average in the top right, is more difficult than most. Average of 1.76. So you'll probably think it's more difficult too, but it gives you some perspective at least. Now, normally FRQ3, your AP exam, FRQ3 will not allow a calculator. This one did allow a calculator. I think up until 2005, the first 3 FRQs were calculator questions, and then the last 3 were no calculator questions. So just to be clear, you can use a calculator on this. Okay, any questions before I set a timer? Let's see how many of these points you can pull out. By the way, I did this one the other day. I always try to do them early, but I think I got 5 of the 9 points the first time I looked at it. The other ones were just careless mistakes, but still. Okay, please start. Oh, just to be clear, it's because there's 2. The back one's going to be optional, at least temporarily. The one I want you to do is the one that's 2005 FRQ3, the front page.
have any recycling?
We don't. there's 15 minutes. So it seemed like the one yesterday was a little bit shorter. This one, of course, since it's harder, probably took a little more time to digest the information. I guess one thing I haven't mentioned is when I share, well, two things. When I shared the average and you guys realize that this is a low average, doesn't that make it feel like a little bit less pressure? Like you're not feeling like you need to be getting 7 or 8 points or something?
Yeah.
I mean, obviously,
I mean, I still
yeah.
struggle with it enough.
But that you need to have the same attitude on the real AP test. Like, if one seems hard, you know, don't beat yourself up over it. It might end up with a low average like this one. It doesn't mean you should quit, move on, come back to it. Some of it you can figure out for sure. The other thing is, practicing one of these at a time I think is good. But of course on the real AP test, you guys are going to have 30 minutes to do 2. They're going to tell you to put up your calculator, and then they're going to give you 4 and give you 60 minutes. It's a lot harder to do 6 in a row than it is to stay focused for one of these. So keep that in mind too. And your actual review, you might make yourself do several in a row because there's definitely something to be said for just being able to stay focused that long. So, okay, so let's look at the scoring here before we go to lunch. So 1 point came from the answer in part A, -7/2. You didn't have to put the units there, and I'll say why in a minute. So the only way you could estimate that from a table is like doing the slope formula, basically. Doing the slope formula from 6 to 8, you can estimate what's happening at 7. Okay, part B had 3 points. 1 point, this should look familiar. This looks like one of the things I put on the when you see this is what you do documents. If you put this somewhere on your work, this is how you would find the average temperature of the wire. So you have to divide by 8 because it has a length of 8 plus how those add up, which you can't do exactly, but you can write that down. This would be like the sum of all of them, divide by 8 makes it the average of all of them. I feel like probably not many people got that one, but I feel like you guys could get that one, especially if you review that. You got 1 point for doing trapezoidal sum. So it said 4 parts. Now this one, I don't know how picky they would be, but here's 1 trapezoid, 2 trapezoids, 3rd trapezoid, 4th trapezoid. Notice those are not equally spaced. From 0 to 1 is much shorter than 1 to 5. And then 5 to 6 is short, 6 to 8 is a different length. These are not always equally spaced. Sometimes they are, sometimes they're not. You have to be paying attention to that. So how I would read this, if I put this on your test, if I could see you try to do a trapezoidal sum, I would give you that point. But for the last point, you have to come up with the answer. So this, the 3 decimal places, 0.688 or 0.687 to get that one. Is that the only way to get this point? There's a lot easier way. I know you had a calculator, but
You just leave it as the trapezoidal sum divided by 8.
you can just leave it just like that. That's all arithmetic.
Well, that doesn't have the 1/8.
Oh, well, yeah, you would need 1/8 out front, I guess.
Yeah.
But if you did the 1/8 as well, then this would be fine for that last point. You don't have to do any arithmetic. So even though you have a calculator, and I will tell you that I didn't think of that when I did it. I tried to put it in the calculator, and I plugged in a wrong number. I had it set up correctly, but I didn't put it in correctly, so that's one of the points I would have missed. Okay, part C, you got 1 point for the value. That was -45. Again, you don't need units. I'm still going to explain why.
Because it says units.
Yeah, well, it's coming. So 1 point if you got negative 45 on C, and then 1 point if you described what that meant. That would mean that it decreased by 45 degrees, or the temperature dropped 45 degrees from one end of the wire to the other end. I said from 0 centimeters to 8 centimeters, so I think that would be okay too. It's describing the length of the wire, from one end of the wire to the other end of the wire. Have y'all gotten 2 points yet? Good. Okay, D, are the data in the table consistent with the assertion that the second derivative is positive for every x between 0 and 8? So for this one, you had to get an answer of no, and your answer had to be backed up with y. Part of your y is you needed to show 2 of the slopes. So they're showing from 1 to 5 and 5 to 6, but you could really do any 2 that showed that the rate of change was not increasing. Second derivative would be like the derivative of the first derivative. So rate of case. Okay, and then last part, we're going to get cut off here in about 30 seconds. The last point, you had to get the units right in A, B, and C. This is why you wouldn't have missed them on the first time. So in A, it was centimeters, or Celsius per centimeters. B, it was Celsius, I'm sorry. And C, it was degrees Celsius as well. If you did all 3 of those units right, you got that point. And if you forgot it once or did it wrong once, you don't get that point.
It's probably too really slow. Like I want to spend like 2 minutes.
Blake doesn't like it.
Yeah, I think it's fine. You know what I was talking to on the way down to the lunchroom? He was like, his was like 4 or 5. I must have 4 or 5 minutes.
See,
Yeah,
he's talking about how he doesn't like it.
so that's like excessive, right? Like I have to talk to the wrong person. Yeah, maybe. I think that's fine.
We're getting Blake to do that. You actually think we're gonna try? It's been insane though.
See,
Did he start?
Yeah.
Usually starts over 10.
No way, that's insane.
I'm joking.
Okay, did everybody get the last point, or see what the last point was on this, so we can move on? Okay, good. All right, so like all of them, obviously I'm happy if you got above average. If you got below average, please put in a significant amount of time on that, and definitely do the back one. But even if you got above average, try to find a point or 2 that you feel like you could get next time. Okay, next on our list is we need, I had missed that last page of things that will be on the AP exam part 2. So we need to look at that. Let's go ahead and finish that together. If you have that numbered in your binder, it should be 131. Okay, so the first two questions were carryover from the other page about points of inflection. And I should have realized that I didn't share any answers with you, so I didn't realize that there was a practice that goes with this. But this piece came from an FRQ. In fact, I think you guys even did this FRQ at some point this year, but one part of it had something to do with points of inflection. So between these, trying to figure out what values of x would be a point of inflection. So what we talked about last time on the previous page is that point of inflections are going to occur when the second derivative is 0 or undefined. Now, I have not emphasized this much, but obviously it makes a big difference what type of graph you're looking at. A lot of times in calculus we're looking at a derivative graph, but sometimes it's actually a function graph, and if it was a function graph, our answers would be completely different. So I can see that this guy is concave up here because the slope of the first derivative is positive. And then when the slope of the, let's try to do it like this. When the slope of the first derivative is negative, it's going to be concave down. So it looks like it's changing concavity at -4. Then it switches back to up, which would be at -2. Or -1, sorry. Looks like the concavity is changing from concave down to concave up at x equals -1. And then the slope of the first derivative goes back to being negative, which means the second derivative is negative, which means the function is concave down, and it looks like it's changing concavity at x equals 2 as well. Okay with that? I meant to have you guys practice these, but since that was my fault, we're just going to briefly discuss them.
The justification would just be like second derivative is greater than 0 or something. Or equal to 0.
Oh, well, for justification, what I would say is something like f of x, or f prime changes from increasing to decreasing. That's about its slope. From increasing to decreasing at -4 and 2, and then at -1 is doing the opposite. F of 1 is switching from decreasing to increasing. Can't use the same justification because why these two are points of inflection, and it's not the same reason these are points of inflection. Again, I don't want to go too fast here where this isn't helpful, but is that enough there? Okay. Then one more about point of inflection. Here was a multiple choice question. And so kind of what I was hinting at just a second ago, and I really didn't plan this, but if you assume this is a first derivative graph, because that's what it usually is, then you're going to make some errors here. This is a function graph. So points of inflection is when concavity changes. Looks like it's switching from concave up to concave down here. There's one time. It's switching from concave down to concave up around here. There's a second time. And then it's switching from concave up to concave down somewhere in here, which would be a third time. If that was a first derivative graph, I would not be working it like that. But that is a regular function graph. I don't know that this applies to y'all, but I had mentioned the year of COVID, the first year when all the AP tests were virtual, and the AP exam was 2 big FRQs. I did have a student, had an A all throughout calculus, and that year one of her FRQs was a graph, and then it was like 10 questions about the graph. She assumed it, I don't remember which one she assumed it was, but it was the other one. And I could see her work, and she would have gotten them all right, and she would have had a 4 or 5. But that year there wasn't you know, there was only 2 big FRQs, so she ended up with a 2. And it would have been one of the least likely people I would have expected that to happen to. But make sure you're not going so fast, or when you're finished and you've got an extra 8 minutes till you can move on anyway, that's the type of stuff you can go back, reread the question a little bit slower, say, wait, I thought that was the first derivative, it's actually just a function. Okay, and then finally, make sure that you know how to do derivatives of natural logs and integrate natural logs. So the part that you would need to have memorized would be the derivative of natural log of x would be 1 over x. Again, I don't know how you wouldn't know that at this point in the year because we've used it 100 times. And then vice versa, if you integrated 1 over x dx, that kind of goes back to the other one, except when you go this direction, you have to do absolute value. Can't take the log of a negative number, so that's not an issue going this direction, but it could be an issue going that direction. Okay, so why don't we look at this last one, and we'll come back to this second one, or the first one. If you were asked to find the slope of a tangent line, that's the same thing as derivative, you would say, well, to take the natural log of something, it's going to be 1 over something like this. But this one would also need what? A 2? Just a 2? Okay. Sorry. 2 and an x because of chain rule. And then if you simplify this, it looks like that. And if you evaluate that at e squared, that's where the answer B came from. So you have to have the derivative for natural logs memorized, and of course you have to consider chain rule, otherwise that question's just fine. Whereas number 22 could be pretty easy if you start off with algebra first. So before I even do derivative on this one, how can I make this, how can I simplify this natural log mess here?
2x.
Right, you could bring the power down. Natural log of e is 1, so 2x times 1 is 2x. So in the end, they were really just asking you what's the derivative of 2x.
And could you have done that on the second one too? Like put the 2 on the outside, or does that not? Can you only do it if it's B?
Now you could, but now if this was like 3x squared, you couldn't bring the 2 down because the 2 wouldn't be an exponent on a 3. It has to be an exponent on the entire thing that you're taking the logarithm of. But yes, you could have. If you'd brought the 2 down and then done the derivative, you would have had 2 times 1 over x, so you would have ended up here. Okay, and so put that aside. I will ask for that soon-ish, but let's look at topics from 3. So again, just me trying to pick out some stuff that you may have forgotten, try to get you a couple practice of each, just trying to help you narrow down what you need to study. All right, so they will certainly ask you about mean value theorem, extreme value theorem, and intermediate value theorem. So mean value theorem is when it says something about instantaneous being the same as the average rate of change. I think you guys are familiar with that. But on an FRQ, if they ask you something and your justification is something about, I think this is yes, or I think this is no. In fact, the FRQ we just did, it had something about mean value theorem in there. You can't use mean value theorem as part of your justification unless you state that mean value theorem works. Mean value theorem only works if it's continuous on the closed interval and differentiable on the open interval. So on an FRQ, if you said yes, mean value theorem, blah, 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 or mean value theorem applies, you have to say because as continuous from 3 to 5 closed brackets and differentiable from 3 to 5 open brackets. Without the proof or showing that it works, it can't be part of your theorem. Okay, extreme value theorem is when we're asked to find the biggest or smallest value. We usually do like a candidates test on this, but for this, it must be continuous on the entire thing. And then IVT is great if you're trying to prove that a y value exists. Yesterday's practice FRQ, we had to find how many times it would be -3 or something. So we were trying to prove or justify how we knew it had to be a certain y value multiple times. And to use IVT, you need to say that it's continuous. And sometimes, this is on that orange slideshow I've been showing you guys, sometimes in the FRQ they will only say it's differentiable. So if you don't say differentiable means continuous, they're not going to accept your IVT justification. So, okay, so I would like you to try these 3 in just a minute. This one got cut off here, but this is a calculator question. I can tell by the number. It's like the first 30, I think, are non-calculator. And we have given this one to you. Sorry, the C is for calculator. We have given this one to you on a test earlier this year, and it was a tough question, but some of you guys were trying to do it without a calculator, I think. So, oops. You should end up, oh, the answer is C, so it doesn't matter. So try that out, make sure that you get C in a moment, D on the next one, and B on the third one. So the first one's about mean value theorem, the second one's an example of extreme value theorem, and the last one's an example of intermediate value theorem. So that should help you identify which of those you might need to ask about. And for this FRQ, the absolute max value was 11 minus 9 pi over 4. Again, I'm sharing the answer with you so that you know if it's right or not when you try it. I think you've actually done that one before too, but that's okay.
Sorry,
Wait,
we're a
what were
little
the
too
answers
fast.
for 24 and 3?
Like just scroll.
Okay.
DMB. Okay, writing an equation of a tangent line and using that to make an approximation. We haven't talked about this in a while, but it does show up sometimes. This one should be B, and the next one should be C. Slope fields. I only put one example on here because I can't imagine you need to practice a bunch of those, but that one is C, so make sure that you work it and get the same thing. And then one more I'd like to do with you is I've got 3 related rates for you at the end, and related rates are important, and we have not talked about them again since first semester. Well, maybe they came up on something else, I don't remember. Now at some point, if you had been in this class 6 years ago, the teacher would have said that this is for sure going to be an FRQ. They used to make this one of the FRQs every single year. And then I don't know if it just became too predictable or something, but then they stopped doing that. So it could come back this year, but regardless, it will be certainly some multiple choice questions. So just like I've been saying in the when you see this is what you do, it's got those steps in there. If you are trying to find the rate increase in cubic inches per second, cubic inches tells me that it's volume. So they're wanting how fast is the volume changing. They share some of these with you. So you should write down the geometry formula. You should take the derivative. Don't forget chain rule / implicit differentiation, whatever you want to call it. These are always with respect to time. So when I take the derivative of r, I need an r prime. And then for these, you just have to use the rest of the information to plug in and solve for what you need. So 4 is a number, pi is a number, r prime they gave me right here, which is 0.3. And they didn't tell me r outright, but they did give me this information. It's when the surface area is 100 pi. So this is why they're given the surface area formula here. And from that you can solve that r needs to be 5. Now this is a no calculator question, so it's a little bit harder to do the computation here. But 5 squared would be 25, times 4 would be 100. And 0.3 is like 3/10. So 300 pi over 10, which reduces to 30 pi.
Okay.
Arithmetic question?
Is the point three is the R1?
0.3 was the r prime. But I changed it to a fraction so I could do it in my head, because this was a no calculator question, so you can just depend on going straight to calculator. I'm going through this quickly, but again, the next question is going to be different. But what it will be similar is that you got to start with the geometry formula. You need to take the derivative. Don't forget the primes. If you take the derivative of r with respect to time, you need an r prime. If you take the derivative of h with respect to time, you need an h prime. Unless you're taking the derivative of t with respect to time, you've got to have the prime piece. Plug in all the information they give you. Some of it will be straightforward, some of it you have to do a little more digging for, but at the end you should have only the thing you're trying to solve for. So I would like you to try just 2 of those, and you should end up with C and A. 31 should be C and 22 should be A. So since we did the other page together, you've got just this one page. So again, you've got 1, 2, 5 questions on the front I'd like you to try. 2, 3, 4 more questions on the back I'd like you to try. So I will give you a few minutes head start, and then I'll come around and see where I can help. Mention I can get my hand on it. I can help with. Okay. The mistake that you have here is because when you're taking the derivative of this, so it's r squared times h, so you have to do product rule. Because there should be some numbers in here that you feel like you didn't use, but if you do product rule, then you'll see why you did them. Okay. I think mine have that in there. Mine had it on there.
And that's when you go to the two over the square root of
Alright, you guys have about 4 minutes. So finish up the one you're on, and between now and next Tuesday, please finish trying all of these.
Does your own homework do or other
But this one makes more sense because then when you take a derivative of that, well, I don't know if it worked. But it worked because this, because of this. Because you plug it into x squared. I don't know what I was intermediate